In the summer of 1962, America aimed a rocket not at an enemy nation, but straight up into the black of space.
Inside its nose cone sat a hydrogen bomb, more powerful than anything ever detonated off this planet.
The mission had a strange, almost poetic name: Starfish Prime. Its goal was simple to state, yet terrifying to imagine: blow up a nuclear weapon 250 miles above Earth.
No one fully knew what would happen when it went off.
Some feared it could damage the very fabric of space itself. Others worried it might set the sky permanently ablaze. And a few, quietly, worried it might trigger something far worse. This is the true story of the day America tested a nuclear bomb in orbit, and the strange, glowing chaos that followed. To understand why, you have to go back to the height of the Cold War. The United States and the Soviet Union were locked in a race for dominance. Not just on land, not just at sea, but now in the emptiness above the clouds. Sputnik had already shocked America in 1957, proving the Soviets could reach orbit first.
Fear spread that space itself could become the next battlefield. Military planners started asking a chilling question.
What would a nuclear explosion actually do, way up in the vacuum of space? Nobody had ever tried it before, at that scale. Scientists knew Earth was wrapped in invisible rings of radiation, called the Van Allen belts. These belts trap charged particles, looping around the planet like an invisible force field. Some researchers wondered if a nuclear blast could disturb or even weaponize those belts. If Earth's own radiation belts could be turned into a weapon, whoever controlled them would have an edge. In September 1961, the Soviets broke a testing pause, restarting atmospheric nuclear tests without warning.
That single move reignited the arms race almost overnight.
The United States responded with Operation Dominic, a sweeping series of nuclear tests across the Pacific. Tucked inside Dominic was a smaller, secretive program: Operation Fishbowl. Fishbowl's entire purpose was to study high-altitude nuclear explosions, far above the atmosphere. 5 separate space detonations were planned as part of this project. The most ambitious and dangerous of them all was Starfish Prime. Its home base would be a tiny strip of coral called Johnston Atoll.
Johnston Atoll sat isolated in the Pacific, roughly 800 miles from Hawaii.
It had already become a launch site for America's boldest nuclear experiments.
Engineers selected a Thor rocket to carry the warhead into position. The weapon itself was a W-49 thermonuclear warhead built at Los Alamos. Its expected yield was about 1.4 megatons of destructive force. That is roughly 90 times more powerful than the bomb dropped on Hiroshima. But this time, the target wasn't a city. The target was empty space,
205 miles straight up.
The first launch attempt came on June 19th, 1962.
It failed almost immediately when one of the rocket's engines shut down mid-flight. The Thor rocket tumbled and had to be destroyed for safety.
Radioactive debris rained down onto Johnston Island itself, a frightening near miss.
It was an embarrassing and dangerous failure for the American military.
Officials regrouped, inspected the wreckage, and prepared for a second attempt.
They renamed the mission Starfish Prime, determined not to fail twice.
Meanwhile, word of the planned test spread far beyond military circles.
Newspapers across the Pacific began reporting on the coming explosion. One Honolulu paper even promised readers a dazzling nighttime show.
Protesters around the world objected, alarmed by the idea of nuclear tests in space.
Yet the countdown continued, unstoppable, toward launch night.
On July 9th, 1962, the final countdown began at Johnston Atoll.
It was just after 11 o'clock at night, local Hawaii time.
The Thor rocket ignited, its engines roaring against the dark Pacific sky.
It climbed steadily, carrying its lethal cargo higher and higher. Radar tracked its ascent as it pierced through Earth's upper atmosphere.
13 minutes and 41 seconds after liftoff, it reached its target altitude.
250 miles above the ocean, the warhead detonated.
In an instant, the sky over the Pacific turned violently, impossibly bright. From Honolulu, 900 miles away, people saw the flash lighting their windows. Witnesses described a blinding white light, exploding into brilliant green and red. The light did not fade quickly, the way a normal explosion would. Instead, it lingered, painting the sky in eerie, shifting colors.
Some described it as an artificial dawn breaking in the middle of the night.
Rooftop parties had actually been planned in Hawaii to watch the spectacle. Hotel guests sipped drinks and cheered as the sky turned crimson above them. They called it, half-jokingly, the Rainbow Bomb. Few realized just how much danger was unfolding above their heads. Nearly 1,000 miles away, on Pacific Islands, the glow was just as vivid. Observers on Kwajalein watched glowing white streaks arc across the horizon. It looked, to many, like the aurora borealis had come to the tropics. But this was not a natural aurora caused by the sun. It was a man-made storm of radiation, ripped from a nuclear blast. The explosion had released a massive pulse of gamma rays and charged particles. Those particles slammed into Earth's magnetic field almost instantly. Within seconds, the effects reached far beyond the visible light show. Back on Oahu, engineers noticed something was seriously wrong. Streetlights across Honolulu suddenly flickered, then went completely dark. Nearly 300 streetlights failed within moments of the detonation. Burglar alarms across the city began wailing for no apparent reason. Telephone lines and radio communications between islands abruptly cut out. Engineers scrambled, confused, trying to understand what had just happened. This was one of the first public demonstrations of something new, the electromagnetic pulse. Scientists had predicted an EMP might occur, but nothing this powerful. The pulse overwhelmed measuring instruments, driving needles completely off their scales. It proved that a single high-altitude blast could disable electronics across a huge region. That realization alone would reshape military thinking for decades to come. But the danger from Starfish Prime didn't stop at the ground. High above Earth, the blast created something entirely unexpected. It formed a brand new radiation belt, artificial and unnaturally intense.
This man-made belt was even stronger than parts of the natural Van Allen belts.
High-energy electrons now circled the planet, trapped by Earth's magnetic field. In 1962, only about 24 satellites orbited the Earth. Within weeks, several of them began to fail, one after another. The intense radiation slowly fried their delicate electronic systems. At least a third of all active satellites suffered serious damage. Among the casualties was Ariel 1, Britain's very first satellite. Telstar, a brand new communications satellite, was launched just one day after the blast. Telstar had been designed to relay live television across the Atlantic Ocean. Tragically, its circuits were damaged almost immediately by the radiation storm. It would eventually fail completely within months, a casualty of Starfish Prime. Engineers realized, almost too late, they had built a hazardous new environment for spacecraft. The very belts meant to protect Earth were now filled with dangerous energy. For a moment, Earth's protective magnetic shield had been ripped wide open. Scientists later described a bubble in the ionosphere, briefly emptied of its natural field. It took nearly 30 seconds for the planet's magnetic field to snap back into place. That brief gap in protection stunned researchers who studied the readings afterward. Down on the ground, most people had no idea any of this occurred. They only remembered a strange, beautiful light in the sky that night. Few understood they had just witnessed a live experiment in planetary-scale physics. Military scientists, meanwhile, pored over mountains of new data. The test had answered some questions, but raised many more troubling ones. If one bomb could do this much damage, what could several do at once? Could an enemy nation use a similar blast to blind an opponent's satellites? Could it silently disable power grids and communication networks across a continent? These questions terrified American strategists more than the light show ever excited them. The Soviet Union, watching closely, ran its own high-altitude tests that same year.
Both superpowers were now aware just how disruptive space-based nuclear blasts could be.
Yet the world was also inching toward its most dangerous moment of the era.
In October 1962, the Cuban Missile Crisis brought humanity to the edge of war.
For 13 tense days, nuclear conflict seemed terrifyingly possible.
President Kennedy and Soviet leader Khrushchev both stepped back from the brink. That crisis changed how both nations viewed nuclear risk going forward.
On November 1st, 1962, both countries conducted their final high-altitude nuclear tests.
It was, remarkably, the very same day the Soviets began removing missiles from Cuba.
Leaders on both sides realized just how close they had come to catastrophe. Something had to change before another miscalculation triggered real disaster.
Negotiations began soon after, aimed at limiting nuclear testing altogether. In July 1963, Kennedy and Khrushchev signed the Limited Nuclear Test Ban Treaty. The treaty banned nuclear explosions in the atmosphere, underwater, and in outer space. Starfish Prime's chaotic results had directly helped push that treaty forward.
The rainbow-colored spectacle over Hawaii had shown the world true cost of these tests.
It wasn't just about explosive power anymore, but about hidden, lingering consequences. The artificial radiation belt Starfish Prime created didn't disappear right away. Traces of it lingered in space for nearly a decade afterward. Some researchers later estimated that the fallout could contribute to thousands of future cancer cases. It was a sobering reminder that space was not an empty, consequence-free frontier. Decisions made in secret briefing rooms could ripple outward for years. They could affect satellites, power grids, and even human health far below. Today, scientists still study Starfish Prime using powerful modern simulations. Researchers at national laboratories have rebuilt the blast in three-dimensional computer models. They want to understand exactly how that electromagnetic pulse behaved in real time. Modern militaries remain deeply concerned about EMP weapons, even now. A single high-altitude nuclear detonation could, in theory, cripple a nation's power grid. Starfish Prime remains the primary real-world data point for that terrifying scenario. It is one of the only times humanity has ever tested such a blast for real. No nation has detonated a nuclear weapon in space since that treaty was signed. International law today strictly forbids nuclear testing beyond Earth's atmosphere.
Yet the legacy of that one July night in 1962 has never fully faded.
It reshaped how engineers design every satellite that leaves our planet today. It reshaped how the military thinks about defending the modern power grid.
and it reshaped global diplomacy, nudging two rival superpowers toward restraint. All of that traces back to a single, blinding flash above the Pacific. A flash that turned Hawaii's night sky into crimson and gold for hours. A flash that knocked out streetlights 900 miles from ground zero. A flash that quietly rewired an invisible band of radiation circling our planet. It began as a Cold War experiment, driven by fear and rivalry. It ended up teaching humanity a lesson about the fragile balance above our heads. Space, it turned out, was never as empty or as safe as it seemed. Starfish Prime remains one of history's strangest chapters. A nuclear bomb detonated among the stars.
And somewhere above us tonight, the echoes of that blast still quietly circle the Earth.